Hey folks, welcome back to another video. Today we're looking at question 1048, longest chain string. The way we'll be approaching this problem is by breaking this problem down into two pieces. The first piece that we'll be breaking it down into is actually sorting out the list based on the length of the given string. So the example one that you see right here is already sorted, and if given here when you sort out the array that's given to us, it would start with xb and anything with 3 letters, then 4, then 5, then 6. So let's do that first. And the thing that you're sorting out is words, and then given a and b, you want to sort out based on length. So length. If you haven't seen this before, this comparator, I highly recommend looking it up on Google. It comes very handy for a lot of problems. Right. So once we have that ready, the next thing that we want is we want to create a hash map, and this hash map will be used as a tool for our dynamic programming approach. So let's initialize that hash map. So what's the next thing that's going to happen? So with every single word that we see in words, what we're going to do is that we're going to take the word and then we're going to remove every single character that we have. So for example, if we have B, D, C, and A, in the first iteration we'll remove B and check if B, D, C, A exists previously. If B, D, C, A exists previously, whatever answer we had for that, we would increment it by 1, and then we would do that for every single letter. So for after we remove B, if we get an answer, we store that. Otherwise, we remove D, try to get an answer and store that, and we keep doing that for every single word. However, since we have stored it based on the length, so you'd start off with A, so you would remove A, and then since it's a single string, it's a single letter, you would say it's an empty string. So does it exist earlier? No, it doesn't, but you would just increment the value of A as 1, and then you would increment the value of B as 1 as well. So as soon as you come to B and A, this third string, you see that once you remove B, you know that A exists previously, right? So, and we have stored the value of A that maps to 1. So we would take that value and increment that by 1. So at this point, the value, the maximum value that you've gotten is 2, and then you come here, right? And then you have a B, C, and A, and then we know that we've seen B, A earlier. So when we remove B, we don't really get anything, but when we remove C, we know that we have seen BA earlier, and we've stored the value of that particular string as 2, so you would increment for this string as 1. So basically you're using two different concepts here. You're using a dynamic programming bottom-up approach, but to store the values, instead of using an array that we would normally use, we are using a hash map because we have to correspond the string with an integer value. I hope that made sense, so let's jump right in. Since we have to iterate through every single string, let's just do W in words. Next up, let's have a variable called max that would store, max is actually 1, since any given string in that could be used. So the max would be 1, and then what do we have next? So for int I equals 0, I less than w dot length, increment I. So let's get a string builder ready. So string builder sb equals new string builder using W, and you would remove every single character to check if it already exists in the map. So you would say s dot delete character at delete character at oh, sb.delete character at sb.delete character at I. You would also want to have another variable called local max, and we will see how it's being used. Right, so what would be local max? Local max, what you're saying is that, hey, with the current word that I'm looking at right now, what is the longest that I can form? What is the longest chain that I can form? So that will be stored in local max, and that will be compared later to reassign max if needed. So local max would be equal to math.max of local max, and it would be map dot get or default. So what are we doing, right? So we're trying to get we're trying to check if this string that we're saying, the new edited string, does it exist in the map already. So if it exists, you would just want to increment the value. If not, you would just want to put that as 0 and add 1 to that. Right, so once that is done, you would do that for every single character in the given word, and then once you're done with the for loop, you want to check for the max. You want to reassign that, so it would be max is equal to math.max of the current maximum value that we've seen or the new value that we have seen. Perfect. So once the for loop is done, you've gone over all of the words for every single word. You've removed each of the characters and checked if something that we've seen earlier can be used to build that. And we've built on top of that. So let's compile this and see if it's okay. So string, let me see where I've gone wrong. You're removing the character I and then local max. Oh, you'd also need to put that in the map. So map.put w and local max. Right, so let's compile this and see if it's okay. Great. Yeah, so that's one of the steps that I've forgotten. Once you have the local max and the word, you need to put that back in the map. Let's compile everything else. Awesome, it looks good. Perfect. So let's talk about the space and the time complexity of the solution. The time complexity of this, like sorting here, would be n log n, and then these are two for loops, so that would be n multiplied by L, so which would be the length of the word itself. So overall it would be n squared, so it would be it would be n squared since there are two for loops, and then that would override n log n right here. And then the space complexity is of n, since we are using the hash map right here. Awesome. So if you have any questions, please let me know in the comments below. Please don't forget to subscribe. I would really appreciate that, and I'll see you all in the next video. Peace.